In this video, I'd like to demonstrate how we can retrieve passwords from the SAM file. So what I'm going to do is I'm going to connect to a CD that I've got on the data store. So if I'm on my Tiger box right now, I powered on my Tiger box. I'm logged in as a student, which I did in the previous video. If you're not logged in as student, you don't have to be. We don't have to know any passwords on this machine to run this tool. So from the CD, I'm going to connect up to an ISO image on a data store. So I've already downloaded something called Ophcrack. So I'm just going to put that CD in. We really would not need to be up and running. I'm not even going to browse it. I'm just going to close this window down. And I want to reboot my machine. So I'm going to just go down to my start menu here. And on this shutdown, I'm just going to go to my restart. And I'm just going to let the machine restart itself. So this is another version of Linux that is called the Ophcrack Live CD. At this point, I'm just going to hit enter to enter the graphic mode. So it's very similar to the last tool we used. Now the last tool, what we did was we read the SAM file and we modified it. We changed the student password, we just blanked it out, and then we were able to log in with the blanked out password. This tool takes a different approach. So again, it's booting off of the CD, and that is our primary operating system. So now it's actually treating our hard drive like a data drive, just how like the other one did. But now what it's doing is it's reading that SAM file and it's pulling in all the hashes. So now we can actually see what these hashes look like. These are one-way ciphers. So the thing that's different, in the last video I said a hash is a one-way cipher. So for example, if I have got a couple prime numbers and I divide them, I may have a whole number and a really long remainder. And if I take that whole number and I just throw it away and I give you the remainder and I said, what two prime numbers were used to generate this remainder, it would be very, very difficult because there are so many different combinations, and it really is. But if you knew both of the prime numbers, you'd be able to rerun that mathematical problem and get the same remainder every time because you knew the primes. In this case, it's a very similar situation with using different hashing algorithms. So there's a lot of different ones. We've got different versions of SHA, which is a very popular hashing algorithm, specifically in the Linux circles. And then we've got the MDs, like the MD5 is very popular in the Windows platform. So we've got different ways that we can take a string, like a password, and run it through like this meat grinder and have something that really can't go back to its original state. So back in the early day, what people did is they would do like a dictionary attack or a brute force attack. And basically a dictionary attack takes a word, runs it through the algorithm, and then says, this is what my hash looks like with the word, and then it compares it against the hash that is inside the SAM file. If those two don't match, it then grabs the next word out of the dictionary, runs it through the hashing algorithm, compares the two hashes, and then continues to go through that process of going word after word after word, hashing them, comparing the hashes. If they don't match, going to the next word. Well, that takes forever. I mean, that seriously is a long, tedious process. And as you can see, I'm already popping up quite a few passwords here. So what some guys did is they realized that we could reverse engineer hashes by pre-calculating hashes. So instead of like brute forcing it, like hackers around the world were like duplicating their efforts by hashing and hashing and hashing and hashing. The word password, I mean, had to have been hashed like thousands and thousands of times. So what this group did is they came up with a concept called a rainbow table. And what they did is they said, well, let's just hash everything in the world and store it inside basically a database. It's a dictionary, but it's basically the same thing, a row and column. And so what they did is they just hashed and hashed and hashed every single combination of uppercase, lowercase, special character. Um, and by hashing all of these different combinations and storing the hashes, now there's a huge repository of pre-calculated hashes. So even though you can't reverse it back out, somebody else has run a specific word through the algorithm. So now if I know that my hash is like E7F8 B2357298 okay, so I know the hash. Basically what I'm going to do is I'm going to query that hash against already pre-hashed results, and that's the rainbow table. So if this is my hash, I query it and I say give me a hash that looks like this, and then it finds that hash inside that table. Well, what word was used to generate that hash is saved in that table, and that's that rainbow table. And then I can say, oh, well, the word reverse was used to generate this hash. Now, these passwords all suck, and that's why they exist inside this bootable CD. Because if you think about a CD, I mean that's only 700 and some meg, so it's not a huge database. Now keep in mind that there are huge databases, so people have gigs and gigs of rainbow tables that can be downloaded. There's even online services that hold like supposedly terabytes of different pre-calculated hashes. So people are actually using this as a service, and they're just hashing every single combination that they can think of, so that way they can recover very complex large passwords. So this gives me an opportunity to talk about passphrases. I'm a big fan of using a passphrase, something that's complicated. Within a password, you can use spaces. So typically what I would do is I would use a password like today is a good day to fish, and then I'd probably throw some numbers on the end like 467, So, and I probably would throw a capital letter in there somewhere. So it's something that wouldn't be in a dictionary. Someone really wouldn't come up with that combination. It's very long, so that makes it fairly complex. So I like passphrases. I'm a big believer in it. The other thing I like with passphrases is it's easier to remember. If my password is today is a good day to fish 768, I'm going to remember that, and I don't need to write it down. Some network administrators come up with very complex passwords where you have to like hold down the Alt key and you got to do like the 762 or something like that and get some type of extended ASCII character. People don't remember that, and typically you find more people writing it down, sticking it in their wallet, putting it underneath their keyboard. I mean, there's tons of horrible nightmares on what people do. So I'm a big fan of that. So it looks like we actually pretty much got all of them. The administrator doesn't have that one yet. And I can actually... The mouse doesn't work the best in this application. So at this point, I think I've got enough to take a screenshot. So what I'm going to do is I always grab this blue bar at the top. I look for the word of the machine. So I kind of move it around so that way I know I've got focus. It's hard to take the screenshot if you're inside the virtual machine. I want to be outside. So this blue title bar lets me know I'm outside the virtual machine. So what I'm going to do, I normally just do the Alt screenshot. If you're on a laptop, you may have to hold down like a function key to do the screen print or print screen. So I'm just going to grab a print screen at this point. I'm going to open up the document that I used from the first video, and I'm just going to put my second screenshot in here so I can basically work on completing the lab. So I've now got two screenshots, which is going to be required for project 1. And actually I think I've got one more screenshot that I'm going to need. Okay, so I let this thing run for about 7 minutes. I can see that it didn't find the administrator password, but it didn't really matter because we know that student is an administrator, and we already blanked that out from the first lab. So at this point, I want to get out of here. The way that I would get out of here is I would pop the disk out. So I'd go to my CD and I'd disconnect from data store image. I'd say yes. And virtual machine, I'm just going to say yes and OK. So I need to get to this exit button. My mouse doesn't work in here. I don't know if that's just the version of Linux or the driver or what, but I see the dotted line is around the save. So I'm going to use my arrow keys. I'm just going to click in here, make sure my mouse is inside the window, and I'm going to try to use my arrow keys to navigate. That's not working. Well, if all else fails, I'll just hit my reset button. And it's not going to let me, so I'm going to go to my VM, do my reset through the power reset. I'll say yes. And I'm going to boot back into Windows. So basically that's using Ophcrack, and that's an overview of hashes.